trigonometric formulas from understanding their derivation to seeing how they are applied in the real world. Whether you are a math enthusiast or just curious, it's my passion to share you my knowledge of how trigonometric formulas work.
So first, we're going to go over the Pythagorean theorem and talk about how to use it to solve problems associated with trigonometry. If you wonder where Pythagorean identities come from, it's pretty simple. You're just going to look at the unit circle here. In the unit circle, we have a radius of 1 and a measure angle of theta. And if we have here a right triangle, this represents the x and this represents the y. The x represents the sine and the y represents the cosine. The Pythagorean relationship is when we have here a Pythagorean theorem that is a squared plus b squared is equals to c squared, and we replace them with sine squared theta plus cosine squared theta, and that will be also equal to 1. To find the other Pythagorean identities, we must first familiarize the fundamental identities for us to be able to derive the other Pythagorean identities. I know that you have already heard the word sakatawa sa tsakaw in your elementaries or even in high schools. These are the ratios that define the relationship between sides and angles in a triangle. We have here the three reciprocal identities and the quotients for us to be able to find the Pythagorean identities. The other Pythagorean identities can be derived similarly using the definitions of trigonometric functions in the Pythagorean theorem. Given a right triangle with sides adjacent, opposite, and hypotenuse, we use the Pythagorean hypotenuse squared is equals to adjacent squared plus opposite squared. We can also rewrite them as a squared plus b squared equals to c squared, as where the c is always the hypotenuse and the a and the b is the adjacent or the opposite. Again, in the unit circle, when we have a coordinate point in the inner circle with a radius of 1 and the angle measure of theta, represents the y is the sine theta, and the x-axis is the cosine theta. Our Pythagorean identities is sine squared theta plus cosine squared theta is equals to 1. We also have its corollary, sine squared theta is equals to 1 minus cosine squared theta, and cosine squared theta is equals to 1 minus sine squared theta. The derivation of the second Pythagorean identities is to divide both sides of the first identity with the first equation cosine squared theta, and through that we are likely to get 1 plus tan squared theta, or the tangent squared theta is equals to secant theta. And to get the third Pythagorean identities, doing the same derivation of the second Pythagorean identities is to divide both sides with sine squared theta, that will likely to result in cotangent squared theta plus 1 is equals to cosecant theta. The sum of everything, our Pythagorean identities is number 1, sine squared theta plus cosine squared theta is equals to 1. If we subtracted both sides with its equation, that will likely to result in other two corollary identities. Our second Pythagorean identities is 1 plus tangent squared theta is equals to secant squared theta, and 1 plus cotangent squared theta is equals to cosecant squared theta. Now, let's practice how we can use Pythagorean identity in solving a problem. Given that sine theta is equals to 4 over 5 and angle theta is between 0 degree and 90 degree, what is the value of cosine? By using our Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. First step is to change sine squared theta into its value 4 over 5. 4 times 4 is equals to 16 and 5 times 5 is equal to 25. Cosine squared theta is equals to 25 over 25. Next step is to calculate the value of cosine by subtracting both sides with 16 over 25. Simplify, and now we have cosine squared theta is equals to 9 over 25. By getting its square root, cosine squared theta is equals to 9 over 25 theta is now cosine theta equals to 3 over 5. And since angle theta is between 0 degree and 90 degree, cosine theta is equals to plus minus 3 over 5, or the positive negative 3 over 5. For us to know what sign should we use, we have here a technique that is called Add sugar to coffee. In quadrant 1, all is positive. In quadrant 2, sine and cosecant is positive. In quadrant 3, tan cotangent is positive. In quadrant 4, cosecant and secant is the positive. So since sine is positive in quadrant 1, final answer is cosine theta is equals to positive 3 over 5. Our second problem says that a window cleaner has a ladder that is 8.1 meters long, and if he places it on the ground such that its top is at the window that is 6.76 meters above the ground, determine the distance of the base of the ladder and the wall. Now I'm sketching here for us to know what is written above that says the top of the ladder is at the window. The ladder is 8.1 meters long and the opposite side is 6.76 meters. By applying Pythagorean theorem, you can determine the value of x. Step 1. Substitute the given values into the Pythagorean theorem. 8.1 squared is equal to 6.76 squared plus x squared. That would be 65.61 is equals to 45.64 plus x squared. To eliminate 45.64, we just need to subtract both sides with 45.64. As we substitute the given values into the Pythagorean theorem, that would be 19.91 is equals to x squared, and if we get its square root, the x will be equals to approximately 4.46 meters. For our next problem, the formulas that we are going to use is the second and the third Pythagorean identities to solve this problem. Our Pythagorean identities, this given is equals to secant squared theta and over cosecant squared theta. The next step is to rewrite the secant and the cosecant with its reciprocal. And since we have here a complex fraction, let's proceed to multiplication. Multiply the numerator to the reciprocal of our denominator, that is equals to sine theta over cosine squared theta, and our quotient, that is tan squared theta. Here's one last problem to tackle. I hope that you've gained learnings about Pythagorean identities with me. So given expression 1 minus cosine squared theta over sine theta cosine theta, the step 1 is use the Pythagorean identities. The sine squared theta plus cosine squared theta equals to 1. As you can remember, we have a corollary identities. So in step 2, 1 minus cosine squared theta is sine squared theta over sine theta cos theta. In step 3, simplify the expression and so on. So in step 4, the remaining ratios sine theta over cosine theta is in quotient, that is tan theta. That's all for today. Thank you for exploring the world of numbers with me. May the Pythagorean identities always guide you to the right solutions. See you around, Math Quizzes!